In this example, I need to rationalize the denominator of the expression 4 divided by the square root of 3 minus 1. We've already learned how to rationalize the denominator when I just have one square root in the denominator. So let's quickly review. If I had 4 divided by the square root of 3, the square root of 3 is simplified. All we do is multiply numerator and denominator by the square root of 3. I get 4 times the square root of 3 divided by the square root of 3 times the square root of 3 is the square root of 9 is 3. Notice that got rid of all the radicals in the denominator. So a lot of students try and do the same process here. What they do is they take your expression 4 divided by the square root of 3 minus 1 and they multiply it by the square root of 3 divided by the square root of 3. Excuse my bad handwriting. So I'm going to get 4 times the square root of 3 divided by, now I'm going to have to distribute this square root of 3 into this parentheses. I'm going to get the square root of 3 times the square root of 3, which is the square root of 9, which is 3, minus 1 times the square root of 3, which is minus the square root of 3. Did that process work? Did I get rid of all the square roots in the denominator? No, I still have this one left. So that process is not useful. It didn't get rid of all the square roots in my denominator. So we're going to have to use a different method, and before I do that, I want to review. Do you remember how to factor a squared minus b squared, the difference of two squares? It factors into a minus b times a plus b. And I want to point out that these two parentheses, I have the same variables in there with just opposite signs. And when I multiply a minus b times a plus b, the middle terms add to 0 and I just get left with the difference of two squares. And that is the process we're going to use to rationalize this denominator. I'm going to take 4 divided by the square root of 3 minus 1. These two expressions here are called conjugates. And I'm going to multiply numerator and denominator by the conjugate of this denominator. So it's the same two numbers, the square root of 3 and 1, with the opposite sign between them. If I multiply the numerator by that, I must multiply the denominator by that, because all I'm really multiplying by is 1. So my numerator, I'm going to have 4 times the square root of 3 plus 1. And this one, I'm going to actually FOIL out the denominator, but you should know from this that we're going to get the difference of two squares. I just want to prove it. So I'm going to get the square root of 3 times the square root of 3, which is the square root of 9, which is 3. Then outer, the square root of 3 times 1 is plus the square root of 3. Inner, negative 1 times the square root of 3 is minus the square root of 3. And last, negative 1 times positive 1 is negative 1. Did my middle two terms add to 0? Yes. And I just lined it up with the first term, the square root of 3 squared, and the last term squared. So I'm going to get 4 times the square root of 3 plus 1 divided by what's left in the denominator. 3 minus 1 is 2. Now can I simplify? Yes. 4 is a factor of the whole numerator, so 2 goes into 2 once, 2 goes into 4 twice. So my answer is 2 times the square root of 3 plus 1. And that is one form of writing my answer. Or I could have distributed the 2 in and got 2 times the square root of 3 plus 2 times 1 is 2. So when you have a binomial with a square root in the denominator, you're going to multiply numerator and denominator by the conjugate of this denominator. That will get rid of all the radicals in your denominator.